So for 7.1 and 7.2, we're going to be graphing exponential growth and exponential decay functions. So at the bottom, you'll see that I have written an exponential function. This is typically what you would see when you're graphing. You may not have an h or a k, but we're going to talk about what the transformations are when you're graphing these. So your a value is similar to if you were graphing a quadratic or an absolute value, but we call this a value, that is the initial point or the initial value. The b in this function is going to be your growth or decay. So we'll talk about in a minute what it means to be a growth or a decay. If you have the minus h, it is similar to whenever we were graphing the quadratics. If you have a minus h, that's going to be your shift to the left or right. So that would be left or right. And then my k will be the obvious shift of whether it shifts up or down. So this would be my up or down shift. So what you have to decide is whether something is a growth or a decay. So here we have both. A growth is something that your b value is greater than 1. So I would say that it is an exponential growth if my b value is greater than 1. So whatever number is right here means that it's greater than 1. It is a decay if my b value is a fraction. A good way to check that is if you had 2 squared, every time you're increasing that exponent, 2 cubed, 2 to the 4th, your value is getting larger. But if you had 1/2 squared is 1/4, 1/2 cubed is 1/8, so it's actually getting smaller and smaller. So you have to decide, is my b value greater than 1 or less than or equal to 1, or between 0 and 1. The domain, I want you to write this in interval notation. So my domain would be from negative infinity to positive infinity. You don't have to put the positive there, it might throw you off. For all exponential functions, your domain will always be the same. So I'm going to go ahead and write that over here to the left. Negative infinity to positive infinity. That just means that this function will go on forever. Here are my 2 graphs if you can't see them. For range, you always start from the bottom and then you work your way to the top. So the range will always be where your horizontal asymptote is, and so this may be a new word for you, but basically this function, what that means is this stretched on forever and ever and ever. It would get stuck at 0 and it would approach x equals 0 forever, but it would actually never touch it. And so with exponential functions, they will always have a horizontal asymptote, and basically that just means that the function's getting really, really, really close as your exponent becomes smaller, but it never actually touches y equals 0. So the range would be, if I'm starting from bottom to top, it starts at 0 and it keeps going all the way to a positive infinity. So basically your range is always, or your asymptote is always going to be this k value here. Starts at 0, goes all the way to the top. So with range here, it's the same thing, 0 to infinity. And my asymptote would be x equals 0 for that as well. And this just takes a little bit of practice. For these examples, they want us to tell whether it's an exponential growth or decay. Remember, it's a growth if my b value is greater than not greater than 0, greater than 1. And it is a decay if my b value is a number between 0 and 1. So if it's a fraction. So I need to identify in 1, 2, and 3, what are my b values? My b values are the numbers that are attached to the x exponent. So in number 1, it would be 1/4. So therefore 1/4 is going to mean that it's an exponential decay. For number 2, 4 would be my b value. So it would be an exponential growth. And number 3, 2.5 would be my b value. So then that is greater than 1, so it would be a growth. For number 4, it wants us to now graph. You can either type it in the calculator and then look at a table, or if you do not have that option, as some of us may not, we're going to learn how to graph it by hand. And so the first step, we need to look at our b value, which in this case is 2. It's going to be greater than 0, or greater than 1. So since b is greater than 1, it would be called an exponential growth function. You may be asked that. Exponential growth function. So the easiest way for me to tell you how to graph these is basically to plot points. So you're going to be plugging in x values, and you're going to be plotting points. Whenever you have an exponential growth, it's a little bit easier to graph just because you end up getting nicer numbers. So we can graph x equals -2, -1, 0, 1, 2, 3, and we'll see what happens. So when I plug in y equals 2 to the -2, that would be the same thing as saying 1/2 squared, which would end up being 1/4. So I can plot -2, 1/4. If I plug in -1, I get 2 to the -1. In that case, it would be 1/2 to the first power, because you bring it to the denominator, it becomes positive, which would be 1/2. So I'm going to plot the point -1, 1/2. It's getting a little bigger. 2 to the 0 power is just 1. So put a point at 0, 1. 2 to the first power is 2. 2 squared is 4. Plot a point at 2, 4. 2 cubed is 8. So plot a point at 3, 8. So what you'll notice if I connect the dots, so I'm going to use a different color. If I connect these dots right here, you'll notice that it's approaching 0. So my horizontal asymptote is going to be at 0, and then it's going to grow exponentially. So if I were asked, what is my asymptote? So my horizontal asymptote is x equals 0. If I were asked my domain and range, my domain is always -infinity to +infinity. My range, it starts at 0 and it goes to +infinity, so 0 to infinity. If it's a growth function, your range will always start from the bottom and go to a +infinity. If it's a decay function, then it'll start from -infinity and then stop at a value. It's a good way to remember. Okay, here we have a 4 times 1/2 to the x. So in this case, my b value is a fraction. So my b value is 1/2. B is less than 1. So this would be considered an exponential decay function. So the best way for us to do this is to graph or to plot points, kind of like we did on the last example, where we have x and y. Now when you're choosing x values, my best advice that I can give you is you want to plug in for this. You want your x to equal 0, and you want your x to equal a -1. And the reason why you want your exponent to be negative when you have a fraction is because if you have a negative exponent, that brings it to a whole number. So if I had 1/2 to the first power, like x equals 1, then that's going to give me a fraction. Or it won't always give you a fraction. In this case, it wouldn't. But oftentimes it gives you a fraction, and you don't want to graph fractions. So if I plug in x equals 0, that ends up getting 4 times 1/2 to the 0 power, which would just be 4 times 1. So I can plot the point 0, 4. Oops. Not here. Then I can plug in x equals a -1. The reason why I choose -1 is because what happens when I choose a negative exponent, so when you do decay, you sometimes want your exponent to be negative. It would be 4 times 1/2 to the -1. And 1/2 to the -1 is the same thing as saying 4 times 2, because if I have this -1, this would now switch places, and the 2 would come to the top. So 2 to the first power, which would give me 8. So I would plot -1, 8, which would be here. So you could connect the dots. You would only need to, if you wanted to try one more, you could try x equals 1, which would be 4 times 1/2, which would give me 2. This one will not always work, so I'm going to put a star by it. You really just have to decide what's best for each function. Each function is going to be conditional, but we'll look at several examples. Since there is no k value, my horizontal asymptote is going to be at x equals 0. And so whenever you plot that, I'm going to connect the dots like this. My domain would be -infinity to +infinity. Range starts from the bottom to the top, so it would be from 0 to +infinity. Okay, the next example we have b is 2, but you'll notice that my exponent is not just x now, it's x minus 1 and plus 3. So now I have an h value and I have a k. So that's going to make things a little bit different. Since my b value is greater than 0, then that would mean that my I have an exponential growth function. So an exponential growth function. I want to get at least 2 points, so I'm going to draw my table. I have x and y. So I can just plug in x equals 1, and I can plug in x equals 2. So when I plug in x equals 1, I get 4, 2 times 1 minus 1 would give me the 0 power plus 3. So 4 times 2 to the 0 power is just 1. 4 times 1 plus 3 gives me a 7. So I can plot a point at 1, 7 right here. For x equals 2, I would get 4 times 2 to the 2 minus 1 plus 3. So that would give me 4 times 2 is 8 plus 3 gives me 11. So plot 2, 11 goes all the way up here. You can barely see it. So you wouldn't really need to test any more points. Just you can connect the dots, but just know that your horizontal asymptote is going to be this K value right here. So I'm just going to draw a dashed line. So it would just curve to the left and then kind of stop at y equals 3. So my horizontal asymptote in this case is going to be y equals 3. My domain would always be negative infinity to positive infinity. My range, it starts at 3 and it goes to a positive infinity. And just try to make your curve as smooth as possible. I know you only have 2 points, but you can make it look like it's curving, and the points don't have to be completely exact. But if you type it in your calculator, you'll also be able to see it as well. For number 7, here is where I would want to find my exponents to be 0 and negative 1. Since I have a b value that is less than 1, it is an exponential decay function. Because my b value is less than 1, so exponential decay. If I were to graph this, I'm going to pick 2 points or 2 x values. So basically I need 2 x values that is going to make this x minus 3 equal 0 and x minus 3 equal a negative 1. So when I get a negative exponent, then that 2 raises to the top, or raises to the numerator, and then it becomes a positive exponent, or it becomes a whole number. So x minus 3 equals 0. If I want to get this one right here, I would need to choose x to equal 3. For the second one, I would need to choose x to equal a 4. So in this case, if I plug in x equals 3 into my function, I get 3 times 1/2 to the 0 power minus 2. 1/2 to the 0 power is just 1, so 3 minus 2 equals 1. So I can plot a point at 3, 1. When I plug in x equals 4, I get 3, 1/2, 4 minus 3 to the, this should be x equals 2. What am I thinking? This should be x equals 2 to give me a negative 1 power. Minus 2. Then if I were to solve the 1/2 to the negative 1 power, this would be like saying 3 times 2 minus 2. 6 minus 2 gives me 4. So I would plot the point 2, 4. Like this. Then I need to connect the dots. But first, before I do that, I need to know where to stop. So if I am looking at my function, this minus 2 would be my asymptote. So -2. So I can connect the dots like this and then stop at y equals -2 is my asymptote. Then my domain and range, domain is always -infinity to +infinity. And my range would be from my asymptote, which is -2 to +infinity. Okay, here we have two equations, exponential growth and exponential decay. The only difference is this stuff in the middle. And so I have 1 plus r and 1 minus r. The r in this case represents my growth rate or my decay rate. So the r represents growth or decay rate. T represents the time in years. And A represents your initial amount. And so if I were comparing this to the exponential function that we talked about earlier, this right here, 1 plus r, would be considered my growth factor, and 1 minus r would be my decay factor. So typically you'll be given word problems where it wants you to find the decay or growth factor, and it'll ask you for that. So here's a word problem. In 2000, the average price of football tickets for Dallas Cowboys was $48.28. I'm sure it's gone way up now. During the next 4 years, the price increased an average of 6% each year. So I'm going to go ahead and take that 6% and write out to the side 0.06. So develop an appropriate model for the average price ticket T years after the year 2000. So I'm going to go ahead and just write the formula by itself. F of t equals A1 plus R, because it's increasing, so that means that it is growth, 1 plus R to the t. Then out to the side, I want to write, okay, what does the problem give me? Does it give me an initial value? It starts out at 48.28, that would be my A. Increase would be growth. My R would be 6%. So I'm going to go ahead and plug in my A value and my R value into the function. I'm going to keep T as it is because it hasn't asked me to plug anything in yet. So F of T would be 48.28, 1 plus 0.06 to the t. You could even simplify this one step further to be 48.28, 1.06 to the t. So estimate the year when the average price was $60. Estimate, so I'm going to plug in for y equals 60. The easiest way for me to tell you to do this right now before we learn other ways to solve is to plug in t equals 1, t equals 2, 3, 4, just kind of a trial and error. And see, okay, which one is going to give me the closest to $60. So when I plug in t equals 1, you end up just getting So I'm going to erase this, and I'm going to make a little chart. So T is time, 1, 2, 3, 4. And this is going to be the price of tickets. So when I plug in X or T equals 1, I end up getting 51.18. If I plug in T equals 2, I get 54.25. And I'm getting this by just plugging into the equation that I found earlier in part A. If I plug in T equals 3, I get 57.50. And when I plug in T equals 4, I end up getting 61 or 60.95. So it would definitely be the year 2004 would be my answer, because that's the one that's closest to $60. Then it says determine the min and max values for the domain that are pertinent to this situation. The domain is my X values, which in this case would be 1, 2, 3, 4. So if I were to graph this, I can start in the year 2000, which would be when T equals 0. That represents the year 2000. Then it says for the next 4 years. So if I add 4, it's 2004. So it would be from 0 to 4. Those are the only values, min and max, that would be okay for this situation, because after 4 years it may increase even more so. Then number 9, a new jet ski costs $4,200 and the value decreases by 10% each year. Decreases right here tells me that it's going to be a decay. 10% would be that R is equal to 0.1, and 4,200 would be my A value. So an exponential decay model, I'm going to rewrite the formula, 1 minus R to the T. It says the value Y, so I'm going to go ahead and change this F of T to Y equals. Remember, F of X, F of T, and Y, they all are the same thing. Then I'm going to plug in the values from the problem. So Y equals 4,200, 1 minus 0.1 to the T. Then it says use the graph to estimate when the value of the jet ski will be $2,500. So my suggestion would be to graph in calculator, then trace the function when Y equals 2,500. So when you graph that and you plug in, so you could plug in T equals 1, T equals 2, T equals 3, you end up getting, whenever the years is 5, you get about 2480.06. So it would be about 5 years.